Okay, now it says find the particular solution. Keyword is find. So that's back to what we were talking about here in A. Now they're asking us to start with the equation for the rate, and they want us to go here and find the equation for the amount. And because the equation for the rate contains the output variable y, we must use the SASE method to do that. So right here, find the particular solution to the given differential equation with this initial condition. They might try and trick you with a different initial condition, so make sure you note that. So now we use the SASE method. So we have dy over dx (1/3 x) y minus 2 squared. First step is always the same. Multiply both sides by dx. Most of the time now, what happens is you end up with one or more factors. So I have a factor here and a factor here. So I'm going to actually multiply both sides by 1 over this factor. So I get 1 all over y minus 2 squared is equal to 1/3 x dx. Oops, forgot the dy. That's 1 point if you get that far. So now we're going to do the antiderivative step. Antiderivative, 1 all over y minus 2. Oops, squared. Interesting. Back up. dy equals antiderivative 1 over 3 x dx. Okay, the squared in the denominator causes problems, so we're going to move that. So we're going to have the antiderivative of y minus 2 to the negative 2 dy. 1/3 is a multiplying constant, so I write it down. The antiderivative of x is x squared over 2. And then I have plus c. This is going to use the expanded rule right here, where a is equal to 1 and b is equal to negative 2. And the n is also negative 2. This is the n. This is the b right here. So this becomes, I don't really want an equal sign there, sorry. So this becomes 1 over a y minus 2, negative 2 plus 1, all divided by negative 2 plus 1, equals 1/3 x squared over 2 plus the constant. They gave 2 points this time for the antiderivatives. So 1 point for each antiderivative. 1 point here, and another point here, total of 3 so far. Okay, this needs to be cleaned up a little bit. So over here on the side, just illustrating what's happening, we have y minus 2 to the negative 1 all over negative 1. Dividing by negative 1 is the same as multiplying by negative 1. So now we have this. This can now be moved to the denominator. So I get negative 1 over y minus 2 to the first, which is just negative 1 divided by y minus 2. So I'm going to use that. So coming up here, we have negative 1 divided by y minus 2 equals x squared, so it's 1/6 x squared. 1/6 x squared plus the constant. So the constant said when x was 1, y is 0. So negative 1 all over y is 0. X is 1. So this becomes negative 1 all over negative 2 equals 1/6 plus c. So this becomes 1/2 positive. And 1/2 minus 1/6, that's equal to c. That work in blue is one more point. So the work in blue is one more point. I don't have to do anything with this. I can leave it like that if I want. It's not that hard to say that's 3/6 minus 1/6, which is 2/6, or 1/3. So c is equal to 1/3. Okay, now I have to take the value of c, go back to this equation here, and do the isolate step. So copy this over. Get some space. Okay, we have negative 1 divided by y minus 2 is equal to 1/6 x squared plus 1/3. I like to look at this as being negative 1 divided by y subtract 2 equals just a bunch of stuff. Because now it becomes easier for me to see that I can multiply the y minus 2 across, and I can move the a, and then add 2, and I'm done. So I have negative 1 divided by all of this was what I called a. I add the 2 across. That's equal to y. That gets me one more point to get that far.